people be? Right? There was a town here. There was, and we knew that there were these structures, these homes, these schools, all this stuff, right? And if it's all in a big pile of rubble, you got to know where to look for people, right? So there's some geography to it. What else is there besides geography, besides GIS?
This is where BGI can help, though.
Okay.
So
example?
If the towers are still up and everything, then you can have people giving reports on where problems are, what streets are blocked, or what people are that need.
So people are contributing, right on the spot, to with their cell phones or smartphones, whatever it happens to be, if that infrastructure is still up. What other problems are there? What other parts of the puzzle are there besides geography? Go ahead, Sita.
I think with the data, we can interpolate like where the next earthquake or where's the risk area. So
okay.
We can evaluate where's the affected area and we can take them to the safe place.
Right. So using spatial interpolation to understand the problem and maybe future problems, both sorts of things. Okay, that's all. We're still talking geography, and that's great. We're still talking about location and GIS, but what other parts are there to this problem? So if we were asked to participate as a mass collaboration for an emergency relief effort, and that's what URIS's GIS Corps is involved with, by the way, if you're ever interested in getting involved with that. That's a big thing that students can get involved with, or any GIS professional. Okay, but what else is there?
There's economics.
Yeah, the economics. What about the politics? Is there any politics involved with this sort of stuff? Well, if it look up and find out what's happening in Turkey with this relief thing, you'll see some politics. Okay, but sir, there's political things that are going on with this, and we can't just blindside ourselves to this and say we're only going to focus on GIS to solving this problem or any problem. There's lots of pieces to this problem and to lots of different problems, and we can't ignore that, of course. The role of GIS continued. So in any of our grand challenges that we look at, I think we can use ArcGIS Server and web services to make all these geospatial data available to everyone. Whatever we have, let's say, or whatever we think is pertinent to solving a problem or some sort of problem. And in that way, we can all help to build the GeoWeb. You might not think that a certain piece of data that you have is useful to anyone. It's something that only we use here. Maybe not. Why not make it available, right? And then someone else might say, oh my gosh, that's exactly what I was looking for. As long as they can find it. And then you need good data discovery tools. ArcGIS Online is very, very good at that. That's becoming a very good resource. So fulfilling our role, right, we can use ArcGIS Server and the web services that we can deploy through ArcGIS Server. So there we have it. Did you know that? Look at there. Esri's ArcGIS Server rocks, it says right there. Let's look at ArcGIS Server's architecture. And this is what we're going to be working on this week. This week you're going to have your hands on the server. You're going to log on as the administrator, start doing some stuff with ArcGIS Server. Those folks who are in remote locations, Boise and Idaho Falls, you'll be connecting up with a remote desktop session. And I'll tell you more about that exercise when we get to the end of this presentation. So ArcGIS Server architecture, there are two ADF choices. What in the world is ADF? Before I go too much farther. Application Developers Framework, Development Framework. Okay, I have put in red the .NET. That is, at this point, principally where Esri seems to be focusing their attention, their forward development of ArcGIS Server. But Java is still a viable alternative. We're going to be doing focusing more on the .NET environment for ArcGIS Server. And you can see this little schematic. We looked at it before, this figure. I think we looked at it last week. And we see all these different applications, ArcGIS Desktop, ArcGIS Engine. Not too much going on there anymore. ArcGIS Explorer, that's the free version. Web Map Viewer, and that's what you guys are going to be creating for the next couple of weeks. And then mobile, ArcGIS Mobile. Well, the data that's behind the scenes that really drive many, many of these things that we just talked about come from services. Okay? And the services are authored by someone just like you. And these services then leverage the capabilities of ArcGIS Server and sometimes ArcSDE technology that you saw and we're working with last week. This data then goes out on Arc Web Services, that's the ArcGIS Online, let's say, or some other services, the services that we provide right here at the GIS Center, Inside Idaho provides, whatever it happens to be. The data that ultimately drives those services then sits oftentimes inside of geodatabases. Could be ArcSDE geodatabases. Used to, we could put them into personal geodatabases. We need to move away from that because the development is not there anymore. We can also deal with file-based geodatabases, and you'll get some experience looking at those things this week as well. So ArcGIS Server then is scalable. Okay, it grows to fit the needs of your enterprise. It's open, Java and HTML, and it also uses .NET, which isn't quite so open, I guess. It's easy for clients to use. It's maybe easier than this previous predecessor, let's say, of ArcGIS Server, which was ArcIMS. Let me tell you what, ArcIMS, which was kind of the first generation of serving maps on the internet, was anything but easy. Okay, there was lots of problems, but you know that always happens. When something brand new comes out, the technology is never very good. It's never perfect, and it takes time for those technologies to evolve and mature and become very, very highly usable and fairly easy to make use of. It's not like it's intuitive, though. But I've got an exercise for you guys. Follow it step by step by step, and it will be like, that's not hard at all. Okay, not too bad. ArcGIS Server can deliver ArcMap MXD project files. When you do that, when you have an MXD ArcMap document that you say, boy, I want to share this with the world, right? What you're doing then is you are creating a map service. Okay? You can also deliver a geodatabase through what's called a geodata service. You can deliver imagery through image services, various flavors of that. You can also create WMS services, web map services, web feature services, WFSs, WCS, web cartography services. There's a bunch of different open source types of services. You can create KML services. What's a KML? Who uses KML? What? Google. There you go. Yeah, that's a Google thing. And then just in general, Arc Web Services. There's another one that isn't on this list here that's really very, very new. It's called the Arc Catalog. Cataloging service, I believe it's called. And what you can do is once you've created maybe some image services and some geodata services, whatever it is, on a server of yours, you can then turn around and create this cataloging service, indexing service on your GIS services, right? And what it does is it allows for much, much easier data discovery, right? Because a person through the search tools in Arc Catalog, in Arc Map, and how many folks have tried the search tools, just looking for data on their own machine? Anyone do that ever? Well, you should try it out. Principles of GIS, I think I wrote in when I taught it a while ago, part of an exercise where I tried to have you do that, and you would do a search for some piece of data that I know was on your machine because I had just given it to you, and you would set this thing up and do a search for it. Oh yeah, I found it. That's cool. You can just search right inside of Arc. Well, what you can also do from Arc's search capabilities is not just search your own hard drive, but point it to a website that has this cataloging service or indexing service built for it, and say you're searching for rivers, well, you might find the GIS Center's got this web service about rivers of Bannock County or rivers of Idaho. You might find something in AGRC down in Utah. Oh, that's exactly what I was looking for, right? Whatever it happens to be. That's a nice tool for data discovery. You can put a lot of stuff out there, and if no one can find it, it's just as good as not out there, right? So you know what I mean by data discovery tools, right?
No, I don't.
No, you don't. How about Idaho Falls and Boise? How do you guys feel about that term data discovery tools?
I mean, do you mean it's specific tools in the ArcMap?
Nope, I mean in a generic sense. What is a data discovery tool? Yeah. Anyone? Can anyone give me a 10-cent definition, change for $1 definition of data discovery tools? What the heck are these? I'll throw out a bunch of buzzwords and phrases, but I start seeing some blank expressions when I say them. I back myself up and want to make sure folks understand it. What's a data discovery tool? Any examples? How about a search engine?
Yeah.
Bing, Google, those data discovery tools? Sure, that's a start. Right? That's been around for a long time, those web crawlers and those search engines, sure. There's other data discovery tools that are being developed, and maybe unfortunately there's tons of those being developed as well. But what a data discovery tool is then, is it's another application, another layer between you and the data that you might want, but that tool helps you locate what you're looking for. Okay, our Esri used to have a data discovery tool that they have since gotten rid of and actually created a better one, which is this ArcGIS Online. Can't recall the name of it anymore. Guess it doesn't too much matter. But what you would do is you'd go out to this website, and you could draw a box around a certain part of this map that they were showing you. This is my geographic area I'm interested in, and I'm looking for rivers, okay, or I'm looking for roads. And you could be more explicit than that, put in a whole bunch of keywords. You click on search, and it goes through and tries to find this data for you. Well, this cataloging service or indexing service that's now available is super powerful, really a powerful tool. ArcGIS Online is very powerful as well. Those are data discovery tools. There's lots of data out there, but now you've got to find it if you want to use it, right? ArcGIS server requires, of course, a server. Now you know what a server is. We talked about that during the first couple of weeks of this class, and we're talking about a real server now. Sufficient hard drive space, because you are going to need to store this geospatial data. You're going to need to store the service itself, the software that runs these services, and in many cases you're going to need to store the cache behind the scenes that allows for far improved performance of your web application, let's say your web map, your image services, and so on and so forth. For instance, the NAEP that we are serving, the 2009 NAEP that we are serving for the state of Idaho, the data itself is 1.4 terabytes in size. That's the raw data. If we were serving just the raw data directly out to all clients, it would not have very good performance. So what we have done is we have built a very large suite of cache behind that image service, and that cache follows Google and Bing cache layering. Okay, that's a very well researched way of doing things, and very fast, very effective. But the cache is about 3 terabytes in size. So don't think that cache, that's just a little something extra. Oh no. No.